Welcome back to Programming Problems. This is episode 7, where we will continue our journey through Advent of Code. We are currently at day 3 of 2015, titled Perfectly Spherical Houses in a Vacuum. In this problem, Santa is delivering presents to an infinite 2D grid of houses. He begins at a start location and gets instructions about where to move next. Moves are always to a house exactly adjacent to the current house that Santa is visiting. The instructions are presented as the 4 cardinal directions using the symbols shown on the screen. Every time that Santa visits a house, he delivers a present, and he might end up visiting some houses more than once. Given a list of instructions, how many houses receive at least one present? Let's take a look at an example. In the first sequence, Santa simply needs to move one time to the right. Given that he also delivers to the house at which he starts in the grid, he thus delivers one present to 2 houses. In the second sequence, Santa has to go north, then east, then south, and then west. Note that he visits the starting house twice, so these 4 instructions lead to delivering presents at only 4 houses. In the last example, Santa has to travel up and down repeatedly, thus only 2 houses end up getting a present. Now, based on the description and these examples, are you already able to write an algorithm for this? Don't forget to sign up at adventofcode.com to get the problem input for this problem and give it a go. Ready? On to the solution. Although the problem takes place on a 2-dimensional grid, what we are interested in is positions which Santa visits 1 or more times. So while we could construct a large 2D grid in hopes that Santa does not go out of bounds, we don't actually need a grid to simply track positions. What we do need is a way to efficiently track unique coordinates. For this, we can use a set, which only ever stores unique elements. Suppose that Santa starts at coordinate 0, 0, then we can create a tuple with this position and we add this to the set. Then if Santa gets an instruction to go north, we simply change the y-coordinate of the current position, and we again add our position to the set. After going through this for all instructions, all that is left is to report the size of the set, because that is the total number of unique positions that Santa visited at least once. Let's go for part 2. The next year, Santa creates a copy of himself, a robot, to deliver presents with him. They both start on the same position on the grid, and then take turns moving based on the same instructions from last year. How many houses receive at least one present this time? Let's take a quick look at only the first example. So both Santa and Robo-Santa start at the same location. After this, Santa takes the first instruction and goes north. Robo-Santa takes the second and goes south. Thus, in total, 3 houses were visited, and that's the answer. Feel free to have a look at the other 2 examples and try to understand how they lead to answers of 4 and 11 respectively. Now let's go to the final part of today's video. The solution for this part is essentially the same as for part 1, but we have to execute it in 2 steps. The first step can be to split the sequence of instructions into 2 separate sequences, one for Santa and one for Robo-Santa. Then you can apply the same algorithm which you already had for part 1. Do be careful, though, that you will have 2 sets, so you need to merge or union those 2 to get the total number of unique positions. The alternative would be to simply use one set and keep track of 2 separate position pointers, and for every instruction add the new Santa or Robo-Santa positions to the same set, which gives you the union for free. And that's it already. 2 more stars in the bank. Thank you so much for watching, and look out for next week's video.